Okay, thank you for that kind introduction. Good afternoon, ladies and gentlemen. I think it's a different, a little different topic I'm talking about. It's more about innovation, and that it's not only about power generation when we talk about a sustainable society. I will present our project, which is the HyGas project combined with a A400 microgas turbine from Aurelia Turbines, a Finnish company. And it's all about the full utilization of watery organic waste. What is this? I'll try to explain in my next slides. So what you can see on this picture is the HyGas recycling plant. And this disposes and treats fermentation residues, manure, and sewage sludge. So it creates in a special process syngas, which is then burned, a high calorific gas, which is then burned in a gas turbine. It's a pretty small plot which you need to operate 24,000 tons a year of fermentation residues. To give you a figure what this is about, it would be the residues of a 200,000 inhabitants city, a small, medium-sized city. This HyGas company is a German-owned company by a company called Schmidt & Kranz Group, a private company owned. Heavy industries for more than 100 years already in business. And it's not only about CO2 regulations, it's about other EU regulations. In this case, it's the Fertilization Directive, which is the key driver for such a solution. And this simply states that in the future, you must not bring out the residues, the manure, the watery waste, the organic waste to the fields anymore, for instance, from biogas plants. How much waste do we really produce? For instance, this is the figure for Germany. So we have organic waste quantities of around 20 million tons of dry substance. 24,000, as I said, we use in that single plant. This is a picture which is made to be remembered. That's the way it is drawn. So what you see on the left side of the picture, it is what we take out from the biogas plant. It's digestate and manure in a certain amount. We mix it, and then we have overcritical water process, where we heat up this overcritical water, and by that, at certain temperature levels, sand and solids, metal salts, nutrients fall out, and last but not least, there is a syngas forming at high temperatures of around 700 degrees. And this syngas we feed into the Aurelia gas turbine, which is a 400 kilowatt gas turbine, and use the power produced not for power generation, just a little surplus goes into the grid. The rest is used to produce the high temperature heat in the process. So here you have the mass and energy balance of this process. So on the left side, for this one particular project, we have 2,500 tons of fermentation residues and 20,000 tons of liquid manure, which enter into that process. And by that, you see the 5 recyclables which come out of that. Electricity, the yellow one, is a surplus of around 200 kilowatt electrical. And this is done by the Aurelia gas turbine. A further recyclable which comes out of this, and we spoke about that already, is the hydrogen. It's enough hydrogen to fuel, for instance, one fuel cell car an hour, which comes out of this project. And the majority part of the recyclables coming out is clean water, which you can lead into the environment without any further treatments, even according to the high German standards. Alternatively, you can put as a fuel, you can put, and my predecessor had already spoken about that, you can have different fuels. So you can use raw sludge, you can use green waste, you can use organic waste, all what you can feed into an organic watery waste portion. So now we come to the gas. Again something which is the gas which is produced here. This is again something which is somehow in line with the presentations you heard before. It is all about turning this organic waste into methane, mostly, some ethane and some hydrogen. The CO2 you see here, which is 34% of CO2, this will form only if you reduce this watery solution. If you have to imagine that you reduce the pressure in this watery solution, and at each step of pressure, there is another gas coming out of this watery solution. And if you extract this gas at 40 bar, for instance, all the CO2 would remain in the watery solution, or almost all the CO2 would remain in the watery solution, so that you obtain a gas at 40 bar, mainly consisting of methane, hydrogen and ethane. This is now the switch to the gas turbine. It's an innovative project on the side of the HyGas project, and it's an innovative solution for the Aurelia's A400 gas turbine design. With all these standard advantages a gas turbine has, like low emissions, no lubricants in this case, low maintenance and high availability. What is a particular advantage of the Aurelia gas turbine is a very high efficiency. I will come to that and describe how this is achieved. The efficiency of this 400 kilowatt machine is above 40%, and even in part load conditions, it is until 40% of a part load, you still have efficiency of more than 40%. And the fuel flexibility, which we need, and because in this case we want to blend the biogas with the syngas we produce in the HyGas. So that we can, as I mentioned, even the CO2, we can handle the content of the CO2, the composition of the gas, and by that it would be a very difficult, a very special gas we can form, an artificial gas, a syngas mixture, which then is burned in this gas turbine. So the key advantages of this Aurelia gas turbine for the HyGas application is that it is the first which outperforms or matches the efficiency of the recipe engines. You see on the left side, on the upper picture on the left side, you see the bulk of all the engines in this power range, around 40%. Some of them higher, but most of them below the 40% efficiency. The gas turbines in that power range are well below the 40%, and we achieve 40% of an efficiency. The fuel flexibility and related emissions is the second advantage why we choose the Aurelia gas turbine. Low maintenance requirement and no oil bearing systems for a clean operation just add to these advantages. A further main topic for us is that due to the modular design of the standard components from standard components of this Aurelia 400, we can choose whether we want to, for instance, adjust the recuperator, the heat recovery skid on the left side in the picture to a certain extent that we add special small streams of smelly gases from our process, things like that. How it works. It is an innovative gas turbine. So it's an intercooled, recuperated two-shaft engine. It's a complex system, but it's not very complicated. So you have two shafts, a lower low pressure shaft and a high pressure shaft. Each equipped with a generator, a compressor, and a turbine. After the low pressure compressor, the compressed air at 3 bars enters an intercooler, and from there it enters the high pressure compressor. So by that, saving a lot of high pressure compression work, leading to a low temperature at the outlet of the high compressor, which then makes the recuperator more efficient. So what you can see here and what we discussed, what was presented in the previous presentations, this is a very low outlet temperature, exhaust temperature of 165 to 180 degrees C. So for combined cycle applications, this might not be sufficient, but for our purpose here, this is a big advantage. And in combined cycle applications where you have cooling, for instance, absorption cooling, or where you have hot water for district heating, this is still a sufficient level of temperature. So the project I was presenting from this disruptive, or I would say innovative plant concept with 2 innovative products is a project which will be built in Germany. It is attached to a biogas plant, so it is a real plant, and where the biogas plant delivers the fermentation residues and all the manure, the liquids from the animal farms surrounding this plant will be delivered to the plant to produce valuable recyclables. It is a certain setup. It will be a leased plant and operated by us. And it's a pretty low investment. If you consider this as an investment for a 200,000 inhabitant city, then this is quite a low equity requirement. What's interesting in Germany, although there is a framework of legal framework, it is quite clear that these permits or this plant development takes a while. So we started in June 2018 for applications for permits, and in December 2018 they have been granted half a year later. And now it took us almost a year to set up the plant, and it will take another year to get into operation. So this was my short presentation of this kind of gas turbine application, of a micro gas turbine application. And we are people from Aurelia at the show, so if you would like to contact them, they can give you detailed answers on their product. Thank you.